Okay, so we are talking about one-dimensional kinematics, but we're also just relating it to a special case of gravitational acceleration. It's just a special case of acceleration being 9.8 meters per second squared down. And so we'll do one or two more problems, and then we'll move on to multiple dimensions. And so we really need to spend some time talking about vectors. But before we get there, let's just talk about g. G is 9.8 meters per second squared down, right? That's the acceleration due to gravity. And I guess just to be a little bit confusing, really we define g as the magnitude of the acceleration due to gravity, and the acceleration due to gravity is g in the down direction. But hopefully when I say g is 9.8 meters per second squared down, we know we mean the acceleration due to gravity is 9.8 meters per second squared down. Okay. So this is often referred to as a g, like 1g, gee whiz, 1g. You hear people talking about g's. How many g's of acceleration? G's of acceleration. So that often we talk about that when we're talking about, let's say, space travel or fast flying airplanes or even roller coasters, right? So when we talk about a roller coaster having 4 G's of acceleration, all that means is that the acceleration is 4 times G. It's got a magnitude of 4 times g, or 4 times 9.8 meters per second squared of acceleration, right? 4 g's of acceleration. It just means 4 times 9.8, which is 39.2 meters per second squared. Now let me just think about what does that mean. We need to understand what that means, right? If a roller coaster has 4 g's of acceleration, or if a fighter pilot is in a plane doing a tight turn, and they do 10 g's of acceleration, which, by the way, is pretty much the human limit that you can withstand before you actually start to have some problems like passing out, etc. Why would you pass out? Why does acceleration mean you pass out? Acceleration means you're changing your velocity, right? So what it means is you're speeding up or slowing down. And the problem is that when you undergo accelerations, when you're speeding up and slowing down, your body is not a solid mass. It's actually a mushy mass. And things in your body can get left behind. So think about the blood circulating inside of your body. When you're accelerating, what happens is the blood has a hard time keeping up with your whole body, and it may not be distributed well to your, let's say, brain, and you pass out. That's really what happens when people pass out when they undergo high accelerations, is that the blood doesn't make it to the brain because it's essentially being left behind. So airline pilots actually, if they're going to be undergoing high accelerations, they tend to do a couple things like wear a pressure suit, which keeps the blood more evenly distributed throughout the body, or they sit in a reclining position so that if they are accelerating, that the blood is more likely to go to the head than to the feet. So anyway, let's talk about what 4 G's of acceleration means. This is, for example, 39.2 meters per second squared. That is like going from it's like going from initial velocity of 0 to a final velocity of 39.2 meters per second in 1 second, right? That's what it means. A velocity change of 39.2 meters per second per second. So the first second, you're going 39.2 meters per second. The second second, you're going twice that, which is about 80 meters per second, etc. So what is this in miles an hour, right? So this is in miles an hour, v0 equals 0 to v final. Miles an hour, well, we can do the unit conversion, but remember, meters per second is about half of miles an hour. So it's around 80 miles per hour in 1 second. So the question is can a roller coaster really go from 0 to 80 in 1 second? And the answer is no. Actually, there are very few vehicles on Earth that can go from 0 to 80 in 1 second. Certainly there are vehicles, but there are very few that have that kind of acceleration. And we'll discuss what this means in a second. But even think about 10 G's, right? A fighter pilot going 10 G's of acceleration. 10 G's is 98 meters per second squared. So that's like going from 0 to 98 meters per second in 1 second. That's going from 0 to 200 miles an hour approximately in 1 second, right? Can anything really go from 0 to 200 miles an hour in 1 second? No, you'd get crushed. That would be way too large a force. So how do these vehicles have these accelerations if they can't have these accelerations? We have actually already answered that question, because to accelerate doesn't just mean to speed up or to slow down. To accelerate means you're either speeding up, slowing down, or changing directions. Because remember, acceleration, which is a vector, is the change in velocity over the change in time. So if we're thinking in one dimension, then we are thinking like this in one dimension, that we're just moving in a straight line, we're speeding up or slowing down. But if we move into 2 dimensions and we go around a corner, you've got an acceleration due to your change in direction. And we will see pretty soon how accelerations depend on change in direction, but that's where you can get the large accelerations. When you have something in particular that's going fast and then changes its direction quickly, that's when you can get these large accelerations. So roller coasters undergo large accelerations when they're going around loops, right? That's where you know that if you've ever been on a roller coaster, and people say where they're most likely to pass out or black out is usually at the bottom of the loop, when they're changing direction. They're going the fastest and changing direction. So that's where your acceleration is the highest. The picture that I drew is meant to be a roller coaster loop, and a roller coaster car is going through that loop. It's going to be going fastest when it gets to the bottom of a hill, and it's going to be accelerating the highest when it's going fastest and going around a curve. So we'll talk more about that when we talk about two-dimensional motion.